Welcome back to the shop, everyone. It's been a little bit. I've been busy with some other projects, but I finally got one done for a friend of mine that I've kind of I stalled on for quite a bit. Lack of interest, too many things going on at work. Just you get the idea. Anyway, I showed this in a previous video before I started working on my display wall, which I'll get back around to that here shortly. I've made quite a bit of progress on it. But I had a vintage exit sign brought to me. Not the first one I've done. This one is melt glass, or some kind of glass with frosting on it. And the one I've done previously was plastic and more triangular than this. But the customer wanted it to be battery powered. I did a lithium-ion battery setup for a relative of hers, and they really liked it. And she wanted one as well. So she sent me this light with a really crappy base. It was the original base, same color as this one. I got this one from Lowe's, and it was pretty well trashed. The plating was peeling off everywhere. It was junk. So I threw that away. Now on the one I did previously, I got all my components from Adafruit. They offer a great selection of lithium-ion battery chargers and batteries, as well as lithium polymer. I decided to go with a flat lithium-ion battery for my first attempt with one of their tiny micro USB charge adapter boards. They're like 3/4 of an inch long and maybe half an inch wide, and it'll charge a standard LiPo or lithium-ion battery pretty easily off a USB connection, and they're like $7. Great value. So I got one of those, and I got a battery, and then I got some ultra bright LEDs. They sold like packs of 100 of them. And I kind of cobbled together a little assembly that would fit into the very limited space inside the base here. I cut a piece of aluminum to fit into the bottom, and made some standoffs to connect the two pieces, cut some holes in the back so that you can hang it on a wall. And all in all, it was kind of kludgy and, just okay for a first attempt, but they liked it. And so when the friend sent me this, a relative sent me this, I kind of started at the same point, went back to Adafruit, looked at the chargers and batteries. This time, though, I went with a different battery, and I went with a slightly better overall internal assembly. So I just wanted to show how I put it together in a small space. So if you have a light similar to this and you just want to buy a base and make some sort of contraption, it's not that hard. So I was already partially in the middle of assembling this, so it's already partially taken apart. I did have a viewer ask me to show this off in case anyone's wondering why on earth I'm even bothering to show this. Someone asked, and I said, yeah, sure, why not? Give me something to do. So nothing fancy about the base here. My first attempt at doing one of these lights, you can see I have the LEDs standing out in space here. This is something new that I'm trying out. But the previous light was plastic and when it was much shorter. And what I did for that was have a piece of perf board in the bottom of the base, and I had 3 LEDs just sort of pointed vertically firing out into it. And that worked well enough. This light, on the other hand, is much thicker material, and the light is diffused a lot more. So I realized that just stuffing 3 LEDs in the end of it was not going to give me enough light dispersion for, like maybe the base would glow, but you get nothing out here. And it's something you want to be able to see at night so you don't bump into something. I think they're going to be using it mostly as a night light. So I decided that the light assembly needed to go out into the same space that an ordinary bulb would. And I looked initially at see if there's any available designs like that on Adafruit's website, because they had a plethora of different LED designs. But there wasn't really anything pre-made that fit the bill that would also run on a low enough voltage that I could get an appropriately sized battery put in here. There's plenty of stuff that's 12 volt rated. I can't squeeze 12 volts into this much space with other junk on the inside of it. That being said, here's my my original attempt I call it the Christmas tree, just stacking the LEDs. And I got the idea from seeing plenty of other hobbyists building three-dimensional electronic functional sculptures, basically. And I thought, well, it doesn't weigh anything, and it's low voltage, and that's a pretty convenient way to make, you know, a structure like this so that the light will come out in all the different areas. So I thought, that's pretty cool. I'll do that. I made 2 of them because the resistors for the anode on these are slightly lower rated than the ones on these. I was playing around with battery life expectancy and brightness to see how much I could squeeze out. Actually, no, sorry. These have a larger resistor on them, and I was not happy with the brightness I was getting. These are a little closer to the 20 milliamp rating of the LEDs, just a little under it. And I'm hoping I should be able to squeeze about 36 hours worth of runtime out of this based on the battery rating. That's a maybe. I haven't tested it out first. I'll probably charge it up all the way today and then turn it on and leave it on and see how far it goes to make sure it's good before I send it off. Anyway, in terms of getting all the guts in there, one of the first things I do with these is I make a base plate. So on this one, it's a little fancier than my first attempt. This is just a piece of aluminum. I can't quite remember the thickness. It might be 1/8 inch aluminum sheet. We had some scrap stock at work, and I just drew on the edge of this with a Sharpie, cut it out using the bandsaw, and then removed metal around the edges until it would drop in there reasonably well. It's actually a slight press fit, but I was happy with it. And then once this was in there, I set it on my drill press, and I just bored 4 holes relatively equidistant to each other. I measured it with a ruler and everything, tried to get them fairly even, and poked 4 holes down all the way down through the aluminum until it came out the back. And then I countersunk all of these holes in here. For example, these are all 440 countersunk screw holes. I think the 440 screws are somewhere around 3/8 of an inch long. These are a little longer. They're a little different. So I made the first 4 here, and between these here and these screws here are some aluminum hex standoffs, the kind that Keystone sells. I started with 1-inchers, but I measured from the top surface of this here, which is very thin stamped sheet metal. I think it's steel. It's something. I measured that it was actually about, I actually wrote on there like 0.948 inches. So I took those standoffs and I shaved them down to that height until I could get this plate in flush with the bottom, and it does stop. And get these 440 screws in the top, and when the whole thing pulls together, it's a nice flat surface. You don't have any of the lip of this aluminum ring showing when this is against a wall. And I still need to wipe the marker off the edge of this, at least. Oh, yeah, it's not screwed on there right now, so... The other thing I need to do is I need to disconnect the battery. This right here is actually the battery cable. You can tell I'm not working with a lot of room right here because the battery cable has to go up through a special hole which I have protected with a piece of heat shrink so that it doesn't shred the battery leads. So I don't need a lithium-ion battery going into thermal runaway on me. So if we lift this off here, you can see there's not a lot to it. Make sure this is all in frame here. I'll bring you in closer. Just ignore all that other crap on the bench. Okay. Let's see if this is visible enough on the viewfinder. So what I have is an old Radio Shack perf board that was actually made for a dual inline package IC. I got a bunch of these when they went out of business. They're great if you're just messing around with a single chip. I grabbed one of these because it was the smallest pre-made perf board I had that had pre-drilled holes and everything, and I figured would fit inside there. I don't actually remember what I used the last time, but it may have been one of these. So this actually came last. The first thing I did with this after getting in my initial 4 hex standoffs here, and making sure those are the right height, making sure they were spaced and everything, once I got those in there, the next step was figuring out how to mount the battery charger. On my first attempt, the battery charger actually laid flush against this panel, and came out the perimeter here. Unfortunately, the base I had at the time was much taller in this bottom section, and so I had much more flat wall to make a small slot in for the USB header to stick out. This was a lot shorter than I anticipated, and I realized I couldn't do that. However, the charger board, which is right here on the side, this cute little guy, I realized that it was short enough that if it was vertical and the USB Type-C port, I went with the newest design because it's most common, this is not tall enough that it would actually interfere with this inner surface right here. It clears it by, like, I don't know, a few thousandths, maybe a tenth of an inch. Actually, that's 100 thousandths, so whatever. It clears it by just enough that I don't have to worry about it rubbing on there. So that was fine. I realized I had to make it vertical. So in order to mount it vertically, I had, whoop, there goes the battery. I had to make a adapter block. And thankfully, on my way out of work one day, my boss left a block of Delrin on my workbench for some reason, and it wound up in my back pocket somehow. I took it home, milled out a small L-shaped bracket here, and bored 4 holes into it. I'm actually not using the 4th hole because there is an LED in the way in the screw head that I'm using. I think they intended for someone to use metric hardware. I don't have any metric taps. So these holes are all tapped for 440, and the 440 screw interferes with the charge LED. So I just left that one out. The 3 here are doing a good enough job holding it in place. So this is an L-shaped Delrin block, wide enough to support this, and also it's a little hard to tell. I have a pointing device. There we go. But I have clearance cut here, and if we look at the top, I also have clearance cut right about here. Sort of a crisscross pattern. I did that on my mill to create space for the solder pads that are underneath it. The wires poke through, and I had originally considered using a chunk of aluminum to make this, but I decided anything conductive, probably not a good idea on the charging board. So with the Delrin, that worked out well enough. And when I originally put this together, I had both of the battery wires, the negative and the positive here, coming off the appropriate battery and ground terminals. Unfortunately, it seems that during my operation of this, I fried the trace between the battery post and the actual battery socket. So now I've got this kind of hacky looking orange wire attached directly to the battery socket and going over to my perf board here. I was not pleased about that. It worked fine 5 minutes ago and then abruptly stopped, and after exhausting every other avenue, I ohmed it out and realized, yeah, I fried the trace. So 60 milliamps. Apparently the trace on here is not rated for that. Don't push it, I guess. So I've got a wire coming off there. Thankfully the charger itself is still working, near as I can tell, so that's good. But I will run this down and then charge it back up to verify all that. Now, the other thing that I had to deal with first time round was how to actually get this thing to turn on and off. At first blush, I decided, oh, I'll just put a switch on it. Easy, you know, flip it on, flip it off. The only switches that I have are toggle switches. Toggle switches are kind of ungainly looking, sticking out. I realize I'm going to have to drill a hole in this base somewhere and either have the switch sticking out the side or drill a hole in this, and then the switch has got to be small enough and flush enough to be on the back of it. And on top of that, if this is mounted on a wall vertically, you're not going to have access to the switch unless you take it off the wall. And I didn't want to design a light where the only way to turn it on and off is to take it off the wall, flip the switch, put it back on the wall, and then have to do the whole thing over again. It kind of defeats the purpose of hanging it on a wall if you have to dismount it to turn it on and off. So I said, what's the lowest profile way I could put a switch on the outside? Now, at the time, I did not think capacitive touch. I've just now realized that would be an option, and I could have considered that. But what I did have, because I had some Arduino packs left over from college that some people got rid of, I did have these cute little membrane switches. They have 4 legs, and it's a little hard to see this one. He is permanently glued into place in there, and I've got 2 of the legs being used for my connection. So that is a momentary push button It's not latching or anything. It's just press it, and it's a normally open contact on one side, normally closed on the other. And yeah, I'm pretty sure Adafruit sells these too, but I had a few of them kicking around, and I used one of those. I realized that this little button here would work out perfectly, and it stuck out just barely enough that if you run your finger over it, you can feel it, and it only requires a little bit of contact force to push it down. So that works great. It's unobtrusive. It's black, so it it works okay with the antique finish on this. Now all I need is a way to turn a single pulse into an on-off signal, which means I need a latch. My original design actually used a latching twin coil relay, teeny tiny little booger, with a diode and capacitor setup so that it would actually act as a D flip-flop. And a single button press would cause it to latch one coil, and then pushing it again would cause it to latch the other way. And I got it to work stable, just fine. And of course, as soon as I got this, I decided, oh, I'll just do that again. What did not occur to me is that I'd never bothered to write down the part number of the relay. I drew out a basic schematic of it, but I never wrote down the relay that I use, and the only latching relays that I do have just absolutely refused to work the way I wanted them to. They would not, well, they'd latch one direction, and then when I tried to get them to reset, they just wouldn't. So that was a waste of time. So I thought, well, crap, I've got to come up with something. There's got to be a purpose-built module or something that will latch for me. And it turns out I was right. All I had to do was go on eBay and look up latching module, and there are these, I'll try to put a link to it on the screen here, reminder for myself at editing to add that in. For $8, I got a 4-pin programmable device that acts as a D flip-flop with a switching sync, or I don't want to say this. It can be configured as normally open or normally closed. It only requires a momentary connection to ground to turn it on or turn it off or change states. And it is a sync type. So instead of providing supply voltage, it is switching ground, which is how this works. So the anode side here is connected to battery positive. The ground side here is connected, and you can't see the devices on the other side of this right now. But it's pretty nifty. I can just barely see it here. Come on, viewfinder. It's that thing right there. It's like the size of my thumbnail. It's tiny, and it's Chinese. I mean, whatever. But it is actually a little programmable device. I think they stated that this would handle up to 1,000 milliamps. It seems a little. I highly doubt that. I'm drawing 60 milliamps. I think that's just fine for this, and it says that it can do inductive loads like relays as well. Or yeah, so I'm just using it to switch this on and off. And what's nice about it is that it doesn't immediately change states as soon as it receives a ground signal. This is actually set up, let me plug the battery in, so that you can change the delay. In this case, if I hold the button in, it takes 1 second before the state changes. Hold it in again, and it turns off. That is actually adjustable using some solder pads on the device. Depending on which solder pads you join together, you can change the delay requirement from 1 second up to about 4 seconds, I believe, according to their little manual. So that was pretty nifty. I set it up for a 1 second delay because I figured 4 seconds just is kind of long. But it's nice because it doesn't have any issues if you accidentally give it like if I press the button like rapidly, or if I just ran my finger over it and just kind of lightly clicked it, it doesn't have any issues with contact bounce. You have to hold it down for it to change state, which means you don't have any issues with it flipping between on and off rapidly because you're mashing the switch or something. So that's a nice feature. The product page states that this has a quiescent current of, I think, 20 microamps. I haven't actually measured it, but I don't doubt it. It's a pretty small device. But again, $8 for that, like $7 for the battery charger. And then for the actual battery, I just went with a, what is this? Super common. Yeah, it's an 18650 lithium-ion cell, 2200 milliamp hours. I estimated that it'll have about a 36-hour battery life, optimistically, if I was to run this just all day and night. And I'm actually going to try that. I'm going to see how far we can get with this. But yeah, that's really about it. Once I got the battery charger installed, the second thing I did was I worked out how I would mount the perf board here, and it wound up being cutting some more 440 standoffs, positioning them in a tighter pattern on the inside here, and that worked out well enough and kept everything out of the way. I was worried that the battery would be so long that I wouldn't be able to fit it anywhere, but it slides in underneath the perf board and stays out of the way just well enough that it all works. Now all I have to do is reassemble this thing, which can be a little tricky because I have to keep the button wires out of the way, and I have to feed the battery connection through this hole right here. Get it up in there with its protective sleeve. Oh, the last thing I did. I realized that on my original design, as far as hanging this, I needed holes in the back plate for like drywall anchors and screws. What I did originally was the two holes right here that are normally used for attaching one of these boxes to a one of these bases to a junction box if you're hanging the receptacle, you know, vertically from a ceiling, or even if you're doing it sideways, whatever. I actually drilled through and I reused those on my first attempt. On this one, I decided, actually I didn't decide, I realized because I'm using this one as an access port for the battery charger connection, that wasn't going to fly, so I was going to have to make new ones. And since I was going to make new ones, I decided to make them even with each other. Just make sure this works now that it's in there. Yay! There was much rejoicing. So that all works. I realized that they really ought to be even with each other, and because of the weight in this, they ought to be up a little bit instead of dead center. So I positioned two brand new ones. I believe I used a... I didn't use a 1/8 end mill. I used a 5/16 end mill to make these holes here, I believe. No. I think I did 5/16 for the little guys and 3/8 for the larger size. These are set up to accommodate a... where'd they go? A number 8 wood screw and hold pretty well. So that's nice. And doing this on my mill, having a mill is really nice. I was able to get the port for the Type the USB-C slot nice and even. That was a 1/8 inch end mill, just one clean pass, and it was perfect. And then these two were, you know, like less than 5 minutes to quickly bore those out. So I really wanted to make use of my fancy machinery while doing this, because my first one was done using a cordless drill in my apartment, and it was sloppy. So this is my first attempt at actually building something with proper tools. Maybe someday I'll even make one of these that's really nice, that's 3D printed or something, man. I don't know, I'm just not into the 3D printer stuff. Another hobby that's really expensive, and I already have a crap load of really expensive hobbies, so I think a little bit of jankiness on this is fine. I know the customer, they know me, and I'm sure they will be perfectly happy with this. I will be happy if this thing meets the battery life expectations that I have for it. Okay, I got the damn thing back together. That was annoying, to say the least. So there's that. Oh, and if you're wondering about the base, I forgot to mention this. The base comes free with every purchase of one of these really, really hideous light fixtures. I have no idea what the hell I'm going to do with the glass part of this, but you know, for $9 I at least got the base and threw away the socket that was in it. Sure, there's plenty of different options. I don't know why they don't just sell these. I mean, I know online they do, but I needed one locally, and yeah. Anyway, it was okay. But we'll just reposition this. Oh yeah, I wanted to put the button at the bottom originally, but I realized having put 2 standoffs in the bottom location, that wasn't going to happen, so I put it off to the side. But I did use the 3 screws here sort of as rough alignment positions. I wanted 1 screw at the top, 2 screws on the sides. I like a little bit of symmetry in design. So, that should all stay there. And unfortunately, in the daylight, it really just... I mean, obviously you can kind of see it light up like that. But, you know, during the day, it's not super noticeable. However, in the dark, I think that'll make a pretty good nightlight. I think it's pretty slick. And you can't really tell that there's a stick with LEDs on it. The glass being diffused kind of hides it, although the end being a little bright and a little wobbly is annoying. That's just a side effect of having a loose structure in there. But can't argue with those results. I'm sure there are probably easier ways, maybe hacking up a flashlight or something to stuff it in there, one of those little push lights that has little cluster LEDs in there. That's always an option. But I don't know. I like fabricating things, and I kind of wanted I wanted an excuse to play around with lithium-ion batteries and stuff. I never really got the chance to do that while I was in college. Was mostly sitting behind a computer. So that's really all there is to it. Yeah, it's just a lithium-ion battery charger, a battery pack, and a toggleable, or a D flip-flop, like a latch module. All the parts came from Adafruit, except the latch. That came from eBay, but there's a number of them on there, and I'll post a link to the one that I used, as well as a link to Adafruit's website, assuming YouTube doesn't smack me for having some sort of fishy link in the description. I am going to get back to working on some other things, but I have one more project from this customer that I need to deal with. That's going to take a little bit more work than this one. And that's this guy. This is an elevator light, and it is beautiful. Very, very thick glass with what I believe is a cast aluminum base. I don't have a magnet handy, but I think this is cast aluminum. And this is very thick glass. They want this to be a solar-powered nightlight. I've done very little work with solar, but thankfully Adafruit makes a whole line of chargers and panels and what have you. That's not the issue. The issue that I'm having is this is very thick glass. I'm going to have to see what I can do about getting a low enough power LED setup that evenly lights this. I'm thinking of going with backlight panels that I can easily run off a 3.7 volt LiPo system that can then be charged with a 5 volt solar array. But we're not going to go into that in this video. I've got to do a little more research and a little bit of planning and purchasing before I can get into this. But as always, thanks for watching. Hope you enjoyed it, and I will be back here soon.